I'm Davide, I'm the Chief Revenue Officer, big title, but we're a small company, so I do much more than just selling.
Hello.
And that's why I'm here with you today. Unfortunately, our CEO couldn't make it. He was supposed to come today, but because of the situation in Israel, he couldn't fly over.
Send him our best.
Will do. Okay, so that's the agenda for today. I'll go through company introduction, but Fred already set the stage, so I would say let's go straight to the topic of the presentation. Let me start by giving you an overview of the company, because I see many of you don't know who we are. So we are a relatively young company. We were founded 2 years ago. The company is based out of Israel, where our CEO and pre-sales teams are located, and founders are located as well. So we might look at as a very young company. In reality, we are leveraging more than 10 years of experience, because the founder of Xinnor used to be the founder of a company called Radix. He sold Radix 2 years back, and he managed to keep the international rights on the intellectual properties. So we are not starting from zero. We started 2 years ago with 10 years of development behind us. Our mission is to be the fastest RAID engine in the market. I assume you're all familiar with what RAID means. So we try to provide resilience, data protection to storage by maximizing performance. We're a small team, 45 people. Most of them are actually developers. We inherited a few people from Radix, and then we were able to hire talents from global OEMs. We have people coming from Dell EMC, we have people coming from HPE, myself coming from Western Digital, and many more. And go ahead.
Quick question. When you say the fastest RAID, you also cover resilience and so on as well, do you?
Yeah.
Because there's a trade-off between all the RAID models, isn't there?
Yeah, absolutely. So RAID is not something new. We are not inventing data protection. We are not inventing data integrity. We do it differently to do it in extremely fast way. I'll explain you why we do that in the next few slides.
So, and you may cover this in the next few slides, but the fastest RAID engine, after RAID was brought out in 1995, I'm going to ask what may sound like an insulting question, but a relevant question: why bother?
Yeah, I get to that. You are spoiling my presentation, which is a good thing, because it means I developed the right slides. So I get to that in a second. We're a small company, but we already have revenues. We have more than 100 petabytes of end-user data that are protected by our RAID engine. And we're a small company, but we have relationship and partnership with very large companies. You see some of the leading SSD vendors. NVIDIA as well is one of our partners. Today we announced partnership with ARM as well, because we were able to port the software to ARM CPU as well. And also some software company, BGFS, the company is called ThinkPark, the company behind BGFS. What we do with those giants, with Western Digital, for example, we have been awarded the Best of Show at Flash Memory Summit. By coincidence, my outfit today is the same. So, sorry about that.
That was in August.
That was in August. I was expecting sunshine in Paris. I haven't been lucky. Yeah, so we have been awarded the Best of Show for the best customer implementation for a solution that we put in place with the BGFS, Western Digital, eBOF, and our RAID engine. But also we do more than that. So those are some of the publications that we released in the last 12 months with key partners. Remarkable one is the one that we will show next week at Computex on Kioxia booth. where we are showcasing PostgreSQL running on our new RAID engine. Last year at Supercomputing with Kioxia, we demonstrated a world record performance from a single server, validated in Kioxia Lab. And again, many more of those solutions with Western Digital, with Atto, compatibility with Limbit as well. So what do we do? I mentioned we do RAID engine. RAID engine is...
Before you get there,
yeah.
You don't show any hyperscale, pardon me, I just took a bite. Are you not allowed to talk about them, or do you not have?
Okay, we don't have anything public with them. We are at the end of my presentation, you will see that our future is there. We believe our future is there, and I will elaborate more on that. Yeah. So what we do RAID engine. That's the core of our IP, and we are very good in the data path, in the way we handle the checksum calculation. We are not the expert on the data management. We are the expert on the data path. So the core of our business, the core of our IP stays on the RAID engine implementation. But also with the RAID engine, we build a solution. So the RAID engine, we branded xiRAID. The solution, we branded xiStore. And today we already have one solution in the market that was a co-development with our partner in Japan. And we're working on new solutions that we will bring to the market in the future. So let's start diving a bit into xiRAID. I'll give you an overview and then I will explain you why do we need a new RAID engine, back to your question. So we have two versions of the code. We have the version, I forgot to tell you, Xinnor stands for Xinnor, which is an ancient instrument in the Bible. So we like to be associated with music because we do data orchestration. That's the idea. So if you see the branding of our product, classical music, Opus, it's an acronym, but it stands for Optimized Performance in User Space. So that's why you might see names that correlates with music.
So what's your death metal version?
Sorry?
So what's your death metal version?
Maybe next one we will call it that way. That's a good question.
So Davide, you talk about two things. First of all, one thing, which is data orchestration.
Yeah.
Data orchestration is often associated with the control part, not the data part, number one.
Yeah.
And number two, do you have a relationship or do you see them as competitors in terms of hammer space?
I cannot comment on the first part of the question. We don't,
the first part.
if we have a relationship, but I can say that we don't see them as a competitor. No,
Okay.
Not for now, no, and not in the foreseeable future as well. So what they do is very different from what we do. We are all about NVMe. We are all about providing the best possible performance. They do orchestration across many different tiers of storage and different silos of storage. That's not what we plan to do. We don't have any ambition to do that even in the future. Okay, so the classic version operates within the Linux kernel. So this is perfect for a local RAID. So if you have a server with a bunch of drive, we work with any drive, but we focus on NVMe drives. That's where we really show the performance. The Opus version, on the other hand, works in user space. And by working in user space, we remove the dependency from the Linux kernel. And also, we become an ideal implementation for virtualization and network attached SSD. With the classic version, we export a Linux block device, which is not possible in user space because of the limitation of the SPDK libraries that we are using. But on the other hand, with the user space, we can address the drive through virt.io, through NVMe over TCP, NVMe over RDMA. We support many features I'll show you later. But when it comes to Opus, we also support NVMe initiator, iSCSI targets, VOS controller. So all features that are really required in disaggregated storage. And that's where we are planning to be in the future. Both of them are managed through a CLI. I'm not showing you any demo because the demo would be very boring because it's CLI commands. We don't have a graphical interface because today those are just a RAID engine. They need to be part of a broader solution. They need to be integrated into a customer solution. And one thing that we're very proud of is the way we handle the CPU. On the classic version, we distribute the load across all the available cores to minimize the load per core and maximize the performance. On the Opus version, we just use a limited number of cores to deliver millions of IOPS. And talking about CPU, classic version works on every x86 server, while the Opus version can also work on ARM processors.
Including Pi?
Today we validated with BlueField 3.
Okay.
So the only validation that we did is with BlueField 3, which has 16 cores.
Mm-hmm.
So that's more than enough, and I will show you later the performance that we can achieve with BlueField 3 from NVIDIA. Why do we need a new RAID? You asked the question earlier. Why do we need something new? It has been invented ages ago. Yes, but at that time there were no very fast media. At that time when RAID was invented, the RAID controller were dealing with the speed of hard disk drive. And then SSD came along, but still working with the same protocol, working in SATA or SAS interfaces. But now with NVMe, the situation is radically changed. So if you look at a traditional hardware RAID, they're attached through a PCIe bus. On a PCIe bus, you have 16 lanes. Each NVMe has 4 lanes. That means if you want to attach more than 4 NVMe, you need more controller, or you can attach them only by 2 lanes, giving up performance. So by design, hardware RAID is limited in the performance.
I think this is PCIe 3, is that right?
PCIe 4 as well, 16 lanes.
Okay.
Yeah.
Well, there were more. They double them every generation?
Yeah, they double every generation, but still, you don't want to do RAID on 4 drives, even 8 drives. So now with artificial intelligence, which is the main driver for enterprise SSD nowadays, the more drive you can have, the better it is.
Absolutely.
So that's a big limitation. And you can do it with hardware RAID. You need more RAID cards, many more RAID cards, and you're limiting the performance because you still go through the PCIe bus. You still operate from a suboptimal ASICs that is on the controller itself.
That's right.
So the alternative is to use software RAID. So there is not just hardware RAID, there is also software RAID. Under Linux, you can find MD-RAID, which we consider being our main competitor because it's free of charge and people like things that they don't need to pay for. What's the limitation with MD-RAID? MD-RAID creates a lock between the stripe and the available and the core of the CPU. So when they try to calculate the checksum, they stick to the same CPU and they create a spike of load on that specific core. So these spikes translate into a bottleneck, which limit the performance. So if you look at MD-RAID, sequential read performance, great, no problem at all. When you start writing data, then it's where it lacks performance. Or even if you go random read, it completely lacks performance. So what's the option for a customer? They can go still with MD-RAID. They do MD-RAID in RAID 10 to get some better performance. But by doing that, they waste 50% of the capacity. And that's very typical implementation nowadays. Or they just go along with RAID 5 and RAID 6 with MD-RAID. But in this case, they waste even more performance, even more suboptimal performance. And the last alternative is just to operate without a RAID. And there are many customers doing that, but if they lose data, if they lose one drive, they lose data. So there's no way back. Okay, so let's talk about us. Let's see why we are different, and that's about our classic implementation. In our classic implementation, we use two main technologies. One is the AVX technology that is available on the x86 CPU. It's the vector extension. We use AVX2. We don't need AVX 512. We get enough performance from AVX2. So through the vectorization combined with the lockless data path. What does it mean? It's the opposite of ND-RAID. So we can dynamically allocate the stripe to the core, to the available core. In that way, we avoid a spike of load on a single core. We can evenly distribute the load across all the available cores, and that's the way to maximize performance over time and minimize load on the CPU at the same time.
And where's the job scheduling done in terms of which, somebody else's question there? Oh, okay. Where's the job scheduling done in terms of which core to distribute to?
It's all done on the system CPU. So the coda is shared across all the available drives, but all the operation goes through the CPU on the classic version.
Okay.
On the Opus version, we decide to take the SPDK libraries. SPDK libraries were developed by Intel back then. They stand for Storage Performance Development Kit, I think the acronym. Great libraries. Many other companies are leveraging those libraries today, but with some limitations. So what we did, we could use the interface to the NVMe. We could use FIO, we could use the SPDK NVMe driver BDEV. We had to redevelop this portion, the BDEV engine for the RAID. We implemented our calculation libraries that we have from the classic version. We created our own control plane. And then when it comes to the connectivity, there was a major bug that we found on the SPDK libraries on multi-thread, and actually we fixed it and we uploaded to the standard. So we made it available for the community. Through multi-thread vHost, we can work on virtualized environment. You can have virtual machine. Through the NVMe TCP or RDMA, then it's NVMe over Fabric type of installation. So what's the benefit? The main benefit is performance. I mentioned we want to be the fastest RAID in the market. Based on our data, based on whatever we tested, we can claim that we are the fastest RAID in the market, including hardware RAID, GPU-assisted RAID, or whatever else.
Can you put some figures on that? So
I'll show you. I have one slide showing a benchmark. I actually have many slides showing benchmark, but let's see where we can dive into, given the time limitation.
And all of this is independent of workload. You can't have workloads.
It cannot be independent. It cannot be. Everything is dependent on workload, number of drives, type of drives, CPU, number of cores. We did many different tests. I'm pretty sure that one competitor might be able to find a corner case where they can claim we're faster, for sure. We tend to show a real-life type of use cases.
A broad flat optimization, not a sharp-pointed optimization.
Absolutely. In reality, what we want is to show best performance in real application. Yeah. Because it's useless to say, yes, we can get the best performance in this corner case that nobody will use.
And are you orders of magnitude greater, or?
Yeah, I'll show you. Okay. I'll show you where we are. When it comes actually to degraded mode, what is degraded mode? Degraded mode, you need a RAID because a drive can fail. And degraded mode is when a drive failed or when a drive has been removed accidentally from the RAID, from the server itself. In that case, you're running without a drive and you need to rebuild the drive. So the system is busy in rebuilding the drive. And that's where we show even higher delta versus our competitors in order of magnitude. So it's not just a percentage delta. And then the third selling point is that we do this by using very little CPU. So on the classic version, for the checksum calculation, because we use the vector extension, we only use about 2% for the checksum calculation. Then, because we operate within the kernel, there is a penalty that is the kernel itself. So overall, we are consuming about 15 to 20% depending on the workload. And that's why we also developed the user space version, the Opus version.
So vector extension is on the CPU?
Yeah. On the CPU,
yeah.
Yes.
Does it take an x86?
Yeah, in this
Intel CPU.
Intel and AMD. AMD is supporting AVX as well.
Oh, okay.
Yeah, both.
Sure.
Yeah. And we use AVX2, which is supported by, if you go back in the last 5 years generation, is supported by both.
Okay. And what do you need the vector extension for? Better calculations?
For the calculation of the checksum.
I got it.
Yeah.
And presumably you produce less heat.
Say it again?
You produce less heat, presumably.
We consume much less power because we use very little CPU, and the CPU is what normally heat inside the server. Yes.
Potentially you can have also better rebuild performance because of the parallelism.
Yeah.
In degraded mode, but also time to recover can be much more faster.
Absolutely. If we have time, I'll show you a few benchmarks. I have them in this deck where we actually... That's a very good point because most of the customers, they look at performance in normal operation. Yeah. But that's not why you buy a RAID. You buy a RAID because you're afraid that something will go wrong. So we always tell the customer, you need to test a degraded mode. You need to test a rebuild time.
Degraded is one aspect, but degraded plus rebuild
is another aspect. Because you have much more workload going on. And that's where we can proudly say we have no competition in that area. Yeah, and actually one of the reasons why we have no competition because alternative solution, they still go through the PCIe bus. And they can work around the PCIe bus in normal operation, not a traditional hardware RAID, but GPU-assisted RAID. They have a way to work around the PCIe bus in normal operation, but they have no way to work around it in rebuild operation. Okay, then what else makes us unique? We mentioned performance in normal operation, performance in degraded mode, flexibility. We can operate with SATA, with SAS, with NVMe drives. We can operate with any vendor drive, any PCIe generation, any capacity. By the way, we have a flat pricing policy per drive. So the higher the capacity, the lower the cost of the RAID for the customer, which is very, very hot topic today for AI because they are deploying massive capacity drives. We support almost every RAID level, 0, 1. Let me say, when it comes to mirroring, that's not our strength. On mirroring, there is no magic. There's not much we can do. Where we really show an advantage is on parity RAID, RAID 5, RAID 6. We also have 7.3, 3 drives parity. We also support all the nested RAID, and we support M+M. So we support erasure coding, where you can have 32 drives in a RAID group for parity, 32 over 64.
On one machine or across multiple systems?
It doesn't matter. It doesn't matter. And actually, per machine, you can have unlimited number of RAID, unlimited number of RAID. Actually, there is a limit, but it's not a realistic limit. In terms of features, we support almost every features. We support a RAID migration, so you can change the RAID level. You can add more drive. We take care of restriping. We can handle a hot spare. You can have a spare drive. We can handle email and LED notification. We have a feature called merge that allows to buffer sequential write so that we minimize the number of read, modify, write operation, and we increase performance for sequential workload. We have our way to protect data in case of power loss, write-all protection. Another interesting features, we support a variable strip size. Strip size is the amount of data that goes on a single drive within a stripe. And by having a variable strip size, we can optimize it based on the RAID geometry, the RAID level, the number of drives, the alignment, the page alignment of the SSD. And by doing that, why does it matter? It matters because we can get best possible performance, but also we can reduce write amplification on the drive itself. So you will see we're working with a leading partner, a leading SSD partner. We're about to release a joint publication where we show that our RAID is perfect for QLC drive because we minimize write amplification on QLC. Then CPU affinity, if you want to limit the amount of core, you can do that and reserve the core to the application. Last but not least, and I have one dedicated slide, we are the only ones supporting high availability. High availability has been in the market for many years for SAS interface. You need dual-ported SAS. There is no easy way to do it on NVMe. And by the next release, which is coming out next week, we are supporting high availability on NVMe. And the solution is software only, no need for any additional hardware, no need for wasting one PCIe port. And that's actually also another important topic, because NVMe today are deployed on small servers, on 1U or 2U servers, where there are not that many PCIe buses. So if you need to allocate one or more PCIe buses for PCIe port for a RAID card, then you don't have space for network connectivity, you don't have space for other type of accelerators.
So what are the reasons people wouldn't use this? I mean, everything looks positive at the moment. You're going to take over the world? I mean,
they don't use it massively because they don't know us. Once they will know us, I'm pretty sure that they will be delighted with what they will see in performance. Normally, when we go into a qualification, the customer at the end becomes a customer as we get into a qualification.
I guess also people would like to have a couple of suppliers of similar technologies, so that they're not putting all their eggs in one basket.
Yeah, we're not totally alone in the market. So there is MD-RAID, which is free of charge, but we are much faster than them. There is Intel VROC, they have a solution, but it's based on MD-RAID. There is another startup, they use GPU. In their case, different approach. We are software only, they need a GPU to run the RAID. Yeah, those are the main competitors. And then there is Broadcom, obviously, with their hardware RAID, and despite all the limitation of hardware RAID, they are Broadcom. So the customer know them, they're everywhere, they are trustful, everybody trusts them, so they have other selling points than us, for sure.
So you bring up GPU, can you take advantage of GPUs?
No,
does
but
it help?
no, we don't need it. We don't need it because we get enough performance from the CPU. Actually, we can even, with the Opus version, we can even operate from ARM CPU. So it's a waste.
But how do you define enough performance? As far as I know, everybody always wants more performance.
Yeah, that's a very good point. So enough depending on the customer requirements.
Yeah.
Yes, if we operate on when we operate from the CPU, we know that our competitor working on the GPU doesn't get to our performance.
Yeah.
So it's pointless to go that way.
So basically enough is more than everybody else has got.
Yeah, enough. And as NVMe will evolve, we saw it from moving from PCIe generation 4 to PCIe generation 5. There has been a huge boost in performance. And in our case, we were able to handle it. But what we noticed, and I show you in the next slide, when we operate within the kernel start becoming the bottleneck. So with the Opus version, with the user space version, we can overcome this bottleneck. But as we stay within the kernel, that would limit the performance.
Yeah. Isn't that true? Every time you fix a bottleneck, another one turns on.
Yeah, for sure. And yeah, we don't need anything else because we use system CPU, system memory, very minimal memory because we don't have a cache on our RAID engine. And also we can deal with local attached NVMe and network attached NVMe, so even in disaggregated storage. So we have a way to handle single I/O errors to avoid failing the drive.
Do you do a write cache?
No, we don't have a cache. We don't have a cache.
You don't want a cache, so you don't have to deal with it because of your performance and...
We don't have a cache because we position the product for NVMe. NVMe is fast enough.
Oh.
You don't need to add a cache. And if you want to add a cache, it would be a volatile cache. Then you need to protect it, and it becomes overcomplicated. So it's.
You need certificated drives, or will any drive do?
Any drive. So
I can just go down to local Aldi and buy half a dozen hard drives.
Okay, sure. Then you will get the performance of the drive that you use. The RAID performance are dictated by the slowest drive within the RAID.
Okay.
So if you take a very slow drive, it will slow down the performance. And it's not us, it's the nature of RAID. Yeah. High availability. From our next release that will come out next week, we are going to support high availability. What does it mean? It means that you can have two servers, two compute nodes sharing the same drives, the same set of drives. You can create some RAID from one server, some RAID from the other servers. In case one server goes down, the RAID will be migrated through pacemaker and core sync to the other server. So there is no disruption. So that means that we can survive not only a drive failure or multiple drive failures, but we can also survive a server failure.
And presumably report it, because otherwise you end up operating a system with several failed drives because it doesn't actually slow down.
Yes. So when the server goes down, then you need to be very careful in managing not just the failover, but also the failback, because the server could come up online. If you don't manage the synchronization, then you end up with corrupted data.
Yeah.
So that's what the pacemaker agent and core sync agent takes care of.
Just two servers or more than two?
So for now, we validated on two servers. We don't see why it shouldn't work with more, but for now, in the current release, it's validated with two servers, and in the next release, we will validate with more. Let me say, today there are not that many hardware options that have two servers in a box on NVMe, and there are no hardware that I'm aware of that have more than two servers in a box. But what we can do, we can also operate through external NVMe, Ethernet attached NVMe, and then at that point you can have multiple servers.
That was actually my thought and question.
Yeah. Okay, numbers. We spoke about numbers. You are super curious to see some numbers. So I mentioned at the beginning that the customer, they often go with MD-RAID because it's free of charge, but it's not very fast, so they implement MD-RAID in RAID 10. If we look at sequential performance in this situation, we tested with 24 NVMe PCIe Gen 5 from Kioxia, and we compare MD-RAID in RAID 10 with our Opus and Classic in RAID 5 and RAID 6. So what's the difference? The difference in RAID 10, if you have 24 drives, you're only using 12 drives for data. The rest is just the replication. In our case, RAID 5, you have just one extra drive. RAID 6, you have just 2 extra drives. So the efficiency in terms of capacity is huge. So you're saving 10 drives in a RAID 6, 11 drives in a RAID 5.
Those numbers don't seem awfully different when I'm misreading them.
They look very similar because in sequential RAID, as I said, MD RAID is doing a good job.
Yeah.
So the benefit here is just you get more capacity in sequential RAID.
Yeah.
And here we're talking about over 300 gigabytes per second. So this is huge. I mean, if you follow the storage industry and if you look at what the new startups are claiming, they raise their hands when they get to 50 gigabytes, when they get to 20 gigabytes. We can achieve from a commodity server, that's a Supermicro server, we can get 300 gigabytes. But there's no much benefit because you can get with the MD RAID as well. Then if we look at RAID, the situation is very different. So MD RAID 10, very inefficient in terms of capacity utilization because you are wasting 50% of it. In RAID 5, we are almost twice as fast. In RAID 6, and between write and read, there is a difference between RAID 5 and RAID 6 because we need to write an additional checksum. The performance is 50% higher than MD RAID in RAID 10. Good? Yep. But then let's look at what happened in random. In random is really where we show massive difference. So when we operate within the kernel, we were able to achieve 24 million IOPS from 24 drives in RAID 5 and RAID 6 in RAID operation against the 1.5 million IOPS in RAID 10 from MD RAID. Hence, when we move outside of the kernel, we get to 65 million IOPS. And similarly, in random write, you see MD RAID deliver in RAID 10 less than 1 million IOPS, and we can get up to 8 million IOPS with our RAID implementation. Those numbers are our numbers, but run on Kioxia Lab, so validated by Kioxia, so they are not just our numbers. So what's the message from this slide? The message is that today NVMe are expensive, and they're getting more and more expensive. People tend to deploy high-capacity NVMe that cost even $2,000–$4,000 per drive. And if you waste 50% of them because of inefficient RAID, you're already throwing away $20,000–$40,000 that you can recover by moving to a more efficient RAID 5 and 6. And in addition to that, you get a boost in the performance. Your question?
Yeah, I'll get there. There's a question in my head. I can't hold the question yet. It'll get there.
You get that absolute reliability, don't you? Absolute resilience.
Yeah.
Yeah.
Yeah, no, I mean, if you implement RAID because you want resilience.
Yeah.
Otherwise, there's no point in implementing RAID.
One thing that worries me a bit about resilience is that if the RAID controller itself fails, you lose your data. So you've got a single point of failure in the RAID controller itself, question mark.
Yeah, that's a valid point against hardware RAID.
Yeah.
You have a single point of failure.
Yeah.
Yeah.
But you've just said that you could run two systems with failover, so that you get around that problem.
Yeah, you can implement, if you are so concerned about a server going down, you can implement high availability. Yeah.
Oh, I know what it is. The objects that we're reading today, right? You talk a lot about random and sequential, but for the most part, objects today that you're reading, or data that you're reading today, is relatively more sequential than it is fully random. We're not doing OLTP anymore. We're not doing minuscule IOPS. We're doing objects files, data that's much bigger chunks, which are laid down on the disk, typically more sequentially than they ever have been. So, in that case, the sequential read is more important, or at the very least, equally important. So, why would I go spend more money when my sequential reads are relatively, if not arguably, the same?
But it's not an archive solution.
Yeah. Yeah.
It's not for archives, not for
No.
TRT.
Even without archive, when we're reading
Database
databases
is
Databases
100% random.
I'm sorry?
Databases are 100% random.
Probably should take that offline. I understand the theory behind that, but the practicality.
But
and reality-
even in AI workload, in the ingestion phase is a sequential read. Then
It's sequential writes, actually.
in the ingestion phase is sequential read. So the GPU is
Okay,
reading the data
that's
from the
fair,
NVMe. Then it run all the calculation, and then there are checkpoints.
Yes.
Checkpoints is a random write that goes
Yeah.
into the storage.
Yes.
And then at the end, they have sequential write down to the storage. So it's not linear. Even just one single application, they are mixing sequential, random write, sequential write. So it's
I'm not disagreeing with that. And that's why we should take it offline. But I'm just saying the whole balance of things, right? Somebody's going to be paying a premium to get your product, and I'm looking at balancing between the premium versus the reality of what you get. So let's take that offline. But
no. Yeah, you have a point, but let me say they are not paying a premium because they are wasting storage capacity in implementing RAID 10. Implementing NVMe in RAID 10 is much more expensive than the license. Yeah, because in RAID 10,
I think I know where you're going.
in RAID 10 you pay 24 drives, you're only using 12.
Okay.
You're only
Fair
using
enough.
12.
Okay.
So you're
Okay, and that's
oversimplifying.
Yeah. Okay. Fair enough. Thank you.
Sorry. I see the performance and the great job you have done on that, but what I don't understand is only to motor xiOpus. What was the plan? To be an OEM? To be what?
Yeah, good point. We're coming to the market strategy, yes. Yeah, we dive a bit too much into the numbers, so let me get to that. Yeah.
I wonder how many people do actually have those sort of numbers available and understand their workloads well enough to make those sort of decisions.
Yeah, I'll show you some real cases that will resonate a bit more than just the absolute numbers.
Designed by an engineer.
Yeah. Okay, the ecosystem. So we operate in Linux only, and we operate with x86, but also with the ARM CPU, any server, any eBOF, any drives. The markets. So, and this probably can help answering your previous question about the workload. So we see today our main market is in the HPC and artificial intelligence space. There is a huge request for NVMe drives for feeding GPUs, keeping the GPU busy. I'm sure you follow NVIDIA, you see they're printing money, they keep on selling their DGX and AGX, but at the end of the day, you need to provide data to those systems, and you need to provide them fast data. That's key, because if they are idle, if they are waiting for data, you're wasting money. So that's our number one market. Then equally important, edge computing. We have customers that they do network monitoring. For example, they do autonomous vehicles where they are loading data into the black box of the machine and of the car, and then they need to offload it to an edge server at the end of the day. So that's all sequential write in that case. We have a genome sequencing customers. They collect data from a microscope, and then they need to write data at 14 gigabytes per second into a server. That's a sequential write only type of application. Well, actually not only, because then they offload it to a tier 2 storage, and then they have sequential read as well. Cloud providers, let me leave it for the end because that's our future. You mentioned earlier cold storage. You wouldn't think about using a faster storage for cold storage. But when you have cold storage, when you have tapes, you need a cache in front of the tape. And I'll show you a case study that we did with Karlsruhe Institute on that. Database acceleration, we mentioned database. That's a very typical application where performance really matters. And then media and entertainment, now as customers are moving to 4K, 8K, for post-production, there are a lot of concurrency operation that needs to be done, and performance matter. Market strategy. Yeah, I like the picture. It might be misunderstood, so let me explain the strategy. So today we are having good success with universities and research institutions because they are early adopters and because they don't have the budget to buy an OEM system. So they come to us and they all have different needs. They might want to use Lastre, they might want to use their BGFS or NFS or ZFS, whatever, but they need performance because they all bought some DGX from NVIDIA because in every university they need to do artificial intelligence nowadays, but they don't have the money to buy a Weka or to buy a VAST Data or to buy a DDN or a NetApp system. So that's where we are getting notice and where we are getting business nowadays.
David, I'm surprised. I'm not seeing military.
They have to kill you after that.
Military, it's not our target market for geopolitical reasons. I told you that we originate from a company that was based in Russia, and we are based now in Israel. So very unlucky from that point. No, we do have customers. We do have customers in federal. We cannot reveal the names, true. Because at the end we comply with any regulation, so we have.
That was my response.
Yeah, we comply with any international regulation, but it's not our target market. System integrators as well, they see us at the end user and they're coming on board. So we're building a network of system integrators. Enterprises, this is mostly database related. We're working with some leading service provider in qualification, so we cannot say that we are in production with them yet. And then to your question about OEMs or cloud providers, we want to sell to them. We don't want to become an OEM. We want to integrate our solution to OEMs, global OEMs. We are working with some of the leading global OEMs. We know that it will take a lot of time before they will embrace our technology because of their way of doing business. So the qualification.
Yeah, but in fact, they are moving on. You know, from TLC, they move to QLC. There will be certainly a FLC with 5 cells in a way.
Yeah.
That means that they will have this problem to have huge IOPS to the disk, whatever. That means that Z will be, and we'll have an interest for them, or in front of the disk, or somewhere, but they need to have this. And all the applications that you showed, that's the point is huge IOPS.
Yeah.
That's all.
Yeah. Some of them, they see us as a competitor. We don't see them as a competitor. We see them as a target customer. We want to OEM our license. We are already OEMing our license to some small OEMs. Ultimately, our goal is to OEM our code to the large guys. And also, last but not least, hyperscaler. You were asking about hyperscaler at the beginning. So the very, very large hyperscalers, they don't need us. They have an army of software developers. I'm pretty sure they will figure out how to get good performance. But then there is a wave of second-tier cloud providers. And nowadays, you get all those artificial intelligence dedicated cloud providers that they don't have expertise in storage. And that's where we want to play.
So now, when you've got a Russian background, you're an Israeli company, there is a huge opportunity in China. And they make up, hang on, this is a real question. They
It's
make
Taiwan
up a
company.
big chunk of the data that's stored around the world. We all forget about them,
Yeah.
right? Between Alibaba, Tencent, etc., there's a huge amount of data. They don't have an issue using your product.
Yeah.
Right? So data cloud providers, number one. Look, let's start with that question, then there's a separate question. Do you have, can you share with us,
Yeah.
around the Chinese market?
Chinese market, we don't have much, to be totally transparent, because it's a tough market. We have a couple of customers over there in the HPC space.
Okay.
I was there last year. I'll be on Monday at Computex. So we are starting investing into the market just as much as the US market. So as a company, the bulk of our business today is, believe it or not, is in Japan.
I do, yeah.
Yep, and we are growing very nicely in Europe, and then our next plan is to grow in the US because it's the biggest market. US is the biggest market, and then Asia is coming next. So I just hired one sales guy for North America, and now I can focus more on Asia.
So you said Japan is a big market. Understand they haven't developed anything in the last 15 years. Europe is a big market, I'm assuming, through universities and
Yes.
research labs in
Yes.
Germany and DACH region.
DACH region, Italy as well.
Okay. Understand about US, etc. One thing you haven't mentioned, are you open or closed source?
No, we're closed source.
Closed source,
Yeah.
that's important, okay.
Yeah.
Okay, because that becomes a challenge for you in some of the
Yes.
cloud providers. Here's the problem. If you went open source, cloud providers, large cloud providers, a very specific large cloud provider will just simply gobble you up and take your open source and run with it. Seen it time and time and time again. So it's a very difficult balance for you as you go into the most prominent, I won't necessarily say the largest, the most prominent cloud providers that are out there.
Yes and no. You mentioned Hammerspace earlier. It's not open source, and they managed.
No, but then they're, like you said, they're focusing on a different space.
But they announced that they sell to Facebook.
Not, yeah, fair enough. Okay, fair enough. I guess I'm looking at your words, cloud providers.
Yeah. So we're not really targeting the very large one.
Okay.
We're not targeting AWS, Azure, or Google Cloud, or Alibaba. We are targeting those cloud providers that are specialized on GPU as a service.
Okay.
And now there are many of those companies that they got a massive funding. They got billions of dollars to build a new data center for a GPU as a service, and they don't have the expertise on storage.
Fair enough.
And that's the one that we're targeting.
Okay.
People like CoreWeave.
People like them, yes.
How expensive are you? I mean, are you commodity pricing to get volume, or are you still selling to a luxury market?
Oh, no. We're not selling to a luxury market. We have customers that are not looking for the extreme. So this technology can become mainstream technology over time because it's very inexpensive in terms of license cost. Where the cost is on the underlying hardware. So the cost of the license is probably we cost as much as one drive within a server of 24 drives. So that gives you 1 to 2 drives cost of the license compared to the rest of the hardware. So we're not offering a complete solution. We're offering a RAID engine. So we need to be competitive with hardware RAID engine from a price perspective, and we are.
And your go-to-market then has to be with system integrators, with I'm jumping ahead, I'm sorry.
Yes, it is. Let's say we are building the network. We have much broader network. I mentioned we have more than 20 partners, but now we are trying to build a network specialized on artificial intelligence. And we have a leading partner in Japan called Core Microsystem. So those are just the public name that I can share in artificial intelligence. Core Microsystem We did co-development, or actually they sponsor some of our development because they are selling to Riken in Japan. Riken is using xiRAID software.
Yep.
It's the largest customer that we have. And in Europe, we started with E4 in Italy, with Megware, NC, Delta in Germany, ABC in Switzerland. In France, we are about to sign up a new system integrator, and we are planning to grow. We have more than this. We have much more than this, but those are the ones that are focused on our future. And we believe our future is more into the artificial intelligence.
So, David, you said 45 people, over 35 are mathematicians, therefore developers.
Yep.
I'm going to take one out for admin. You're left with about 7 people. Of that, how many are actually doing, let's just call business development?
Let's say customer-facing people, we are 7-8 people, customer-facing.
Okay.
So including the CEO. The CEO is very active with
Okay.
Customer engagement, even though he's a super techie guy.
Okay.
I'm the least techie guy in the company.
Customer facing, including, and did you mention in the beginning your revenue, you're getting revenue, are you profitable?
No, we're not profitable. We are a startup. We know it's a long journey. We are self-founded.
I was just going to say, you're self-funded,
We're
you're earning about 8 million to 10 million a year.
No, we're not burning that much money because we have revenue, but we are not profitable. We are not burning that much cash. We're also very careful in our spending, so we're a bit different from traditional storage startup that they go out and get hundreds of millions and they burn it, hoping to grow up. In our case, our founder wants to keep the control of the company and until we achieve a certain level of revenue. So we're not actively looking for any VC money or any institutional investors, at least for the next 1 or 2 years.
So not too many Porsches in the car park.
If we do it now, there are no Porsche in the car park. Yes, but if we go to the VC now, we would dilute too much the equity. So it's not the right time. So we are new into the market. We need to build our network. We need to build our revenue, and then we can look for money. So
you can do an IPO. Can you remain private?
Nobody knows. I mean, that's something that time will tell. The goal of our founder is to build something remarkable in the industry. Yeah. So he won't be satisfied if we build a $10 million company.
Yeah.
So he has very high ambition, and he keep on reminding me that he has high ambitions, just to put some pressure. But that's the goal. So we want to grow up. For now, we do it organically. Yeah. We don't need VC for now. But,
so you go for the unicorn?
This will take some time, but that's the goal. That's the goal. Why not?
Go for it.
So you used the word "we will get too diluted." Does that mean there's more than just the founder's money that's invested, and is it fully employee owned?
It's fully employee owned. Yes. Yes.
Will you say something about your solution, xiStore?
Yes, I'll get to that, but before getting there, I don't know how much more time. Fred, do you know how much more
tons
time?
Of time.
We have 1 second, 29 minutes and 14 seconds.
Okay, 14 seconds.
11, 10, 9, 8.
Okay, good. Let's talk a bit about real cases before we get to the solution, and then I will skip a portion to get to the key message I wanted to convey. So real cases, people are buying DGX and then they need to provide storage to DGX. In this case, with Delta Computer in Germany, for a university in Germany, they wanted to use NFS. So you can use xiRAID with NFS and get with just 18 drives in RAID 50 and 2 drives in RAID 10, we were able to achieve 50 gigabytes per second, which is the maximum possible performance with a 400 gigabit InfiniBand network. So we were limited by the network. So if you look at those numbers and compare it to the new guys, the storage startup that are unicorn already, we're probably 2 to 3 times faster with just one commodity server and with NFS.
Sorry? You mean you're allowing these people to compete with GPU direct type?
Yeah, it could. Yes. So the solution is to provide very high performance to GPU. We don't support GPU direct for now. We are not certified by NVIDIA as well, because that certification is super expensive, time and resource expensive. One day we'll do it, but for now, customers who cannot afford the other guys, they don't care. I mean, as long as they get the performance, they don't care. So that one was with NFS. Those two cases, or actually three cases, one in Italy, one in Singapore, using BGFS. Same use cases. In this case, they needed to provide storage to more DGX. And in case this one in Germany, it's a very large installation. It's a 4 petabyte all-flash installation that we did. In that case, they wanted to use Lustre, actually competing with Weka in this case, and we have been awarded the business. So these will be public case studies. I'm not showing the name of the company because we still didn't publish the case study, but those will be public, hopefully, in the next few months. ZFS. Many people are using ZFS. It's still one of the most common file system in the market. And ZFS is great, except when it comes to performance with NVMe. When it comes to NVMe performance, we did some testing. With 16 drives, we get maximum 50% of the theoretical performance of those 16 drives. And that's because of the uneven distribution of the load on the cores. You see that there are spikes on some cores and very little load on other cores. Very similar to what happened with NVRAID.
When you say that, it's really ZFS or OpenZFS?
OpenZFS. Yep. So by replacing RAID Z, which is RAID 5, and RAID Z 2, which is RAID 6, with our xiRAID, we are able to double the performance of ZFS. So this is a blog post which is available on our website, but it's also a major university implementation.
This is probably a silly question, but mainframes run Linux. Mainframes run big databases with lots of speed needed. Are you seeing any applications for this in the mainframe space, or are they fast enough already?
We didn't actively look for it,
Yeah.
and so far we don't have any customer in that space. Might be, but we are not really pursuing it.
But they'd be parallel processing and sort of fairly optimized for I/O for a long time. So
yeah, normally they are very close environments, so I don't know if they can use third-party software. So we never.
Well, it's open mainframe these days, so
yeah, good suggestion. Databases. We did a paper which will actually be showcased at Computex next week on Kioxia booth on PostgreSQL, comparing an implementation versus MD-RAID. And what you see, let's go straight to the results. Select only means read, random read. Update is random writing. You see the number speaks by themselves. I don't need to comment the numbers. You see the benefit that we bring into the performance. And we do have several customers that are using xiRAID for database acceleration. We have customers doing high frequency trading where performance really matters, or also enterprise databases. And then we mentioned cold storage. We have a case study which is on our website, but also on their website. The company is again a research institution, Karlsruhe Institute of Technology, and I like this case study because they publish it without asking us, and the results are very much in our favor. They compare a NetApp HDD-based system with 128 terabyte HDD. compared to 2 Dell ME5024 with 2 times 48 SAS SSD, compared with one single server with 10 NVMe. And the results is that they get 10x the performance. Those are not our numbers. Those are published on Karlsruhe website, Karlsruhe Institute KIT, they call themselves, website. They show 10x benefit in the performance from a solution which is much cheaper and much more optimized in terms of real estate. So cold storage, you might think is a sequential, writing to tape. They have 100 petabytes of tape libraries. In the paper that they wrote it's an extremely random operation because there is a mix of read and writes that keep on going on when you have such large tape libraries.
Are you talking to people who do tape library systems?
I would like to.
PowerPoint, spectrology?
Yeah, we had some conversation with them, but it's very early days. Very early days. Yeah, but that's something that we should be doing. Absolutely. And the last one, I mentioned media and entertainment is another market. We announced a collaboration with Synesys.io in the US. And they released 2 products. One is a workstation based on NVMe. The other one is a SAN file system, where they showed over 50 gigabytes per second from the workstation. And with 16 drives, they achieve over 100 gigabytes per second. So they're about to release those products to the market. That's a kind of OEM agreement for us. So they are integrating our software into their product, and they are selling themselves the product.
How do you physically implement this? Because you're not using a PCI bus, so you've got to plug the drive into something. What does it actually plug into?
Software.
So
the software is loaded on the CPU.
Yeah.
So you don't need to plug the software. You just go to the central repository, upload the license, and we provide the permanent license to the customer.
So you could envisage a time when every server comes with this as an option or comes with as a default.
Yeah, good point. We have a customer in the US that they want to do that. They want to put a trial license by default on every NVMe server.
Yeah.
And then it will be the end customer deciding if they need it or if they don't need it. Yeah.
Yeah. And it seems that you'd like to have RAID as an option. I can't imagine why you wouldn't want to have RAID as an option.
Yeah. Absolutely. That's a business model that we are considering with a partner, and we are trying to convince other partners to do the same. The beauty of software is that you don't need to ship anything. So if you want to try, anybody can try. We can provide a trial license and everybody can prove our statements. Let me skip those slides because otherwise we don't get to the main topic. I had many more numbers about performance, but this would be boring.
Benchmarks always bother me a bit because there's a feeling that some people have optimized their hardware for particular benchmarks. Right back to when Oracle used to have a switch that said, if you're running a benchmark, click your switch box.
You know, any benchmark, I wouldn't trust any benchmark. Yeah. Because who is running the benchmark, they have an objective in mind. They want to prove they're better than the others. So that's why I'm not, I just show you one slide instead of many more. It's a software. You want to try? You try. And you derive your own numbers.
But you need to be mature enough to be able to measure your
Yes, that's correct. And we noticed that not everybody is so knowledgeable in the industry. Even people that are supposed to be knowledgeable, they need some level of education. And actually, we have a blog post on our website explaining how to run proper benchmark, how to do proper preconditioning on the drives, what to measure, how to measure it. Because it's not easy. It's a complicated task.
Well, politics inside a company is, if somebody wants to buy new kit to build up their position in the company, they will fiddle the benchmark service to make sure they buy whatever it is they want to buy.
Yeah, absolutely.
Yeah.
Okay, let's talk a bit about the solution. Today we have the solution, we brand them as xiStore. And the solution that we have today was co-developed with Core Micro, actually developed by us, sponsored by Core Microsystem in Japan. And it's a solution which integrates xiRAID with the Lastre parallel file system to provide a very fast, scalable, and flexible solution. It's made of building blocks. Each building block is made of 2 servers connected to shared drives, and the shared drives can be NVMe drives or they can be hard disk drive, traditional hard disk drive. This solution is meant for a predominantly HPC workload, traditional HPC workload, where HDD are still very commonly used. So what we did in this solution, beside the RAID engine, we built the high availability between the 2 servers. So if one goes down, the other one is taking over. We create a control plane for mounting virtual machine, and on the virtual machine we are mounting Lastre. When we deal with a hard disk, the beauty of the solution are performance, because we only care about performance. Performance with NVMe, they comes from the xiRAID implementation. Performance with hard disk drive, we develop a decluster RAID. Decluster RAID is a different type of RAID. In traditional RAID, you have data and parity. In decluster RAID, you also distribute spare. So you have spare drives. Instead of having a spare drive, you are distributing the spread across all the available drives. That's because when you lose one drive, you have more drives where to write the data into. So you have much higher level of parallelism in rebuilding the failing drive. So the reliability comes from the RAID implementation, from the high availability cluster, but also we have silent data corruption, so we can scan in background all the blocks to look for potential data corruption. And these are run on commodity hardware. So that's a big difference from other OEMs. In this case, our main competitor are companies like DDN or like HPE ClusterStor, who are offering solution based on Lastre. They offer a hardware and a software type of solution. In our case, it's software only and can run on commodity hardware.
Question, have you spoken to AWS's FSx people for Lastre?
No. No.
Talking afterwards.
Okay.
On the commission?
I just happen to know who runs the division. So.
Oh, very good, very good. Great. So a few numbers. When we run on NVMe, we are able to achieve from just 24 drives, 80 gigabyte per second IOR. IOR is the benchmark at Lastre level, so after the file system.
Yes. Most of the time, in your target markets, files are very large. That means, do you have some reference architecture or configuration to these special large files? Because it's not the same way to have this wonderful IOPS that we can have normally, and these large files that we could have in energy, or this kind of thing.
Yeah, this product is targeting traditional HPC. In traditional HPC, the files tend to be larger files. Yeah, you're absolutely right. So in this case, that's why you don't see IOPS in the slides for xiStore. We're quoting sequential performance because it's more a throughput that matters in this case. Back to your point, in this case, it's very sequential type of operation. Yeah, and also when we operate on HDD, the minimum building block, you need 2 servers connected to 2 JBODs. We can achieve very good performance, so 21 gigabyte per second read and write from just 2 servers connected to 2 JBODs with 168 drives. But let's say one of the peculiarity of this solution is the decluster RAID. So as I say, D-class RAID, okay, 15 minutes, I'm good. D-class RAID means that we're distributing data, parity, and spare so that we can have more concurrency in the rebuild process. If you look at today, the high capacity drive, a 24 terabyte, I believe is the highest capacity. Actually, they have a 30 terabyte, but nobody can buy it. But let's say what you can buy at the 24 terabyte, it takes about 2 days to rebuild the drive. With D-class RAID, we are able to reduce this almost by 10 times. We're able to do it in 5-6 hours. We're not the only one. ZFS has a D-class RAID implementation. And if we compare ourselves, our D-class RAID to ZFS D-class RAID, we're still faster by 2.6 times.
But then you have to run ZFS.
No, it's a comparison.
No, I'm saying that then you'd have to be running ZFS itself, which has its own challenges.
Sure. Okay, so that's our current solution. As I said, it was not coming from an R&D lab. It came from a specific requirement of the end customer in Japan, and that's why we had to we did such implementation. Now, what's next? What's the future of the company? Now we are the fastest RAID engine. We want to sell this RAID engine to as many clients, as many customers as possible, and we are far away from that, from achieving that, because we started new just 2 years ago. But then, from a development standpoint, where do we see us in the future? In 2 areas, and actually it's one area, and it's a cloud and AI, and most of the time it's a combination of cloud AI. What can we do there? This is a new concept that we are working on, and we are validating with some of our leading, they're not customers yet, but leading potential customers. When you talk to the cloud, primarily the cloud AI, they need scale. It's a huge installation. They don't have one DGX. They have thousands of DGX. They have multiple customers, and each of their customers, they have a preference for a different file system. So they want to run a virtualization with multiple tenants, each tenant running its own software, its own file systems. They want data resiliency. Many of them, they do replica, or they do 3 times replication, just to make sure that they don't lose data no matter what. And they are very sensitive to power and CPU consumption, because they need to allocate all the power to the GPU. So the more you can reduce CPU load, the better it is. So now that we have xiRAID Opus running in user space, we can think about developing a solution that meets all of those requirements. So we can think about having disaggregated NVMe that are RAID protected through xiRAID Opus, and then through vHost we can connect directly to the virtual machine, or we can connect through a file server where we can mount Lastre or BGFS or NFS on top. So this will give great flexibility to the cloud guys, because each of their customers will be able to use the file system they're familiar with. The other big advantage is that if we were trying to do this with RAID within the kernel, we would be limited in the performance, because as we run into the kernel in vHost implementation, there is a limit of 250K IOPS running through vHost, and we can overcome it and get to 8 million IOPS from just 8 core in this case. And the sequential performance that you see here, they were achieved with a single core. So it's extremely optimized in terms of CPU utilization.
Anybody running cluster or Ceph?
That's a good question. Ceph, we don't have customer on Ceph. We have a lot of interest on GPFS. We have a lot of interest on Scale, now they call it Scale. Yes.
When your owner comes in and tells you about his ambitions as a company, what keeps you awake at night? What could go wrong? What are the things that worry you about?
The speed of the growth.
Yeah.
So we're a small team, so it's we are engaged on many different activities.
So it's marketing, really.
It's more marketing, and yeah, it's the bandwidth to be in front of the customers and to be visible by the customer.
Yeah.
Do you have a US presence? Is there a US company that goes along with it?
We don't have a US entity. We have patents in the US. We have IPs in the US, and we hire one guy who is based in Europe, but will be dedicated to the US market. He just came on board on Monday. He has a lot of experience in the US market, a lot of connection to the US market, but he's working with our so it's easier for us to handle from that perspective. So moving on, now that we have this concept that we can create this disaggregated infrastructure with the flexibility of different file systems, with the xiRAID Opus, we can also think about deploying it in a sort of distributed erasure coding. So I mentioned the cloud guys, they don't want anything to go wrong. So they don't want to lose data if a drive goes down. They don't want to lose data in case a server goes down. So what we can do, we can distribute the RAID across drives in different servers. And by doing that, we can survive not only multiple drives failings, but we can survive also the case where a node or multiple nodes are failing. So that's the next evolution we're working on.
I can understand that. What does distributed erasure coding actually mean?
Okay, so that's more a semantic question than anything else. We call it RAID. Some of our customers or competitors, they prefer referring to it to erasure coding. If you look at Wikipedia, there are synonymous.
Yeah.
In other blogs, there are differences. Normally, you refer to erasure coding when it's distributed. So it's not in a single server. It's across multiple servers and when you have multiple parity. But we have multiple parity on RAID as well. We can do distributed RAID as well. So in this slide, we call it erasure coding. Maybe in the future, we will just go back to our traditional name of RAID. But it's the same type of implementation at the end.
Once you see sort of distributed erasure coding, I'm sort of not quite sure.
Because there are some people very sensitive to the terminology of erasure coding. So by adding the sort, we try to smooth their sensitivity.
It's worth looking on Wikipedia. I'll go there.
Yeah, and I only have a few minutes left and 3 more slides. Bluefield. So we managed to validate running the code on Bluefield. Bluefield is the data processing unit of NVIDIA. So it's supposed to be much cheaper than a CPU, and it's meant to do networking capability. So Bluefield does InfiniBand connectivity. And today you find, so let me go fast. Well, actually, you find Bluefield inside DGX already. So what we did, actually this was done together with NVIDIA in their lab. They gave us access to their lab. We tested with 6 Samsung drives, and without any RAID implementation, those are the performance in the different workload. And then after RAID implementation, you can see that we still achieve basically the same performance in RAID, very good performance in sequential write. Random write, it looks much lower as a number, but don't forget that when you do RAID 5, you have 4 operations. You have 2 reads and 2 writes. When you do RAID 6, you have 6 operations. So it's a natural penalty of implementing a RAID in random operation. So if we look at the theoretical performance, we are within 60 to 100% of what can be achievable. So when I say good enough, that's good enough. I mean, if you stay within 60 to 100% of the theoretical maximum. That can be, for some of the customers, is good enough.
I asked the question about Pi before. I want to suggest you guys think about doing that, because you're saying it doesn't take a lot of CPU for a tech guy, particularly in an enterprise, to play with this at home, because you know he's got a Pi somewhere, and be able to prove that and then take it in the office. You've got that VMware amplification that you can get.
Yeah, you can, but you need to have multiple NVMe. You need to have.
You're suggesting that these people don't?
No. Many of them they do. Many of them they do, and so
that's why I'm suggesting that if they can have a look at that, play with it at home, demonstrate that multiple of these people will have multiple Pis, for example.
Yeah. All right. I have one last slide.
That's absolutely fine.
One last slide. So since we can operate from Bluefield 3, we can think about providing storage without a server. So that's ultimately the idea. So you can have AGX or DGX from NVIDIA. They already comes with the Bluefield inside and some NVMe. We can think about loading the code on Bluefield, connecting through a switch to disaggregated storage without a server. So in this case, you save the CPU, you save the DRAM, you save the server chassis, saving power and a lot of hardware. So for now, this is a concept. It's not something we're taking to the market. We are validating with NVIDIA, we're validating with potential clients. But those are ideas for our future. So we are the RAID company today, and we can do more than just RAID in the future.